Welcome to Astronomy Daily. I'm Anna, your host for today. You're tuning into the podcast that brings you the most fascinating updates from the final frontier. Whether you're an avid stargazer, a space enthusiast, or just curious about the universe, you're in the right place. In today's episode, we've got a thrilling lineup of stories from the world of astronomy. We'll delve into a recent NASA mishap that caused a stir on social media, explore the ambitious Einstein telescope project poised to revolutionize our understanding of gravitational waves, and take a closer look at a critical spacewalk investigating space microbes. We'll also discuss NASA's groundbreaking mission to create artificial stars, revisit a remarkable binary star system with the Hubble Space Telescope, and catch up on China's latest lunar exploration achievements with their mini rover on the moon's far side. So sit back, relax, and let's embark on this cosmic journey together.
The Astronomy Daily Podcast.
On June 13th, NASA inadvertently sparked a flurry of speculation and concern following the accidental broadcast of a simulated emergency. During a routine training session, audio was mistakenly transmitted to their live YouTube channel, suggesting that an astronaut on the International Space Station was suffering from decompression sickness. The realism of the simulation led many listeners to believe a serious incident was unfolding in real time. The simulation audio included tense commands to get Commander back in his suit, check his pulse, and provide oxygen, with one voice stating the astronaut's prognosis was tenuous. Understandably, this caused alarm among space enthusiasts and the wider public as snippets of the audio proliferated across social media platforms. Speculation about a true emergency on the ISS quickly gained momentum. NASA soon stepped in to clarify the situation. The official ISS account on X reassured everyone that the audio was from a training simulation, not an actual emergency. The timing of the broadcast coincided with the crew's sleep period, during which no real activities were happening on the ISS. According to NASA, the crew was preparing for a spacewalk scheduled for the following morning. Decompression sickness is a known hazard in space, caused by gas bubbles forming in the bloodstream due to changes in atmospheric pressure. Also known as the bends, it can lead to serious health issues and even be fatal. However, on this occasion, all astronauts were safe and sound, asleep, with no actual emergency occurring. NASA's quick response and clear communication helped to quell the rising wave of concern, though it served as a reminder of the delicate nature of space operations and the level of preparedness required to handle potential crises. The mishap also highlighted the rigorous training and simulation processes in place to ensure astronaut safety. Let's dive into something truly groundbreaking in the world of astronomy: the Einstein telescope. Imagine, if you will, a device so sensitive that it can detect the faint ripples caused by catastrophic cosmic events, like the collisions of black holes and neutron stars. This is what the Einstein telescope aims to achieve. It's not just a telescope, it's a gravitational wave detector poised to open new chapters in our understanding of the universe. The Einstein telescope will employ cutting-edge laser technology to measure these gravitational waves with unmatched precision. If successful, it will allow scientists to study phenomena that were once beyond our reach. This telescope won't be sitting in a single country. Plans are underway to build it in an optimal location straddling the borders of Germany, Belgium, and the Netherlands. This border triangle provides the geology and seismological stability required for such sensitive measurements. Gravitational waves themselves are fascinating. They're essentially the universe's own way of sending out SOS signals during massive cosmic events. The summer of 2017 offered a tantalizing preview of what we might be able to routinely observe with more advanced detectors. That year, astronomers around the world united in excitement when gravitational waves from a neutron star collision were detected. This once-hidden event shed light on the cosmic forges that create elements like gold and platinum. The Einstein telescope stands to amplify this kind of discovery dramatically. Unlike its predecessors, it's expected to be 10 times more sensitive, enabling it to scrutinize larger swaths of the universe. This doesn't just mean more data. It means unprecedented detail and context for every signal captured. But here's something incredibly cool. The Einstein telescope won't work alone. It's part of an international network of detectors, including America's Cosmic Explorer. Together, these infrastructures will provide a full spectrum view of cosmic events, integrating data from gravitational waves and electromagnetic signals. Think of it as giving astronomers both eyes and ears on the cosmos, ensuring we don't miss a thing. Cutting-edge laser interferometers form the heart of these detectors. They detect the minuscule changes in distance that gravitational waves cause when they pass by. And when I say minuscule, I mean it. A shift smaller than the diameter of a proton. The economic and scientific impacts of constructing such a massive project are immense. The construction alone involves burrowing out extensive tunnels and setting up kilometers of vacuum pipes. Countless scientists and engineers are already gearing up to create the new lasers and instrumentation required for these next-generation measurements. So, why should you be excited about the Einstein telescope? In essence, it will let us peer further back in time than ever before, uncovering secrets of star formation, galaxy birth, and those all-important cosmic collisions. If astronomy has entered an era where our understanding is driven by the gold rush of data, the Einstein telescope is poised to be our most valuable pickaxe, unearthing treasures hidden in the fabric of space-time itself. The Expedition 71 crew aboard the International Space Station is gearing up for a crucial spacewalk scheduled for today. NASA astronauts Tracy C. Dyson and Matthew Dominic will venture out of the Quest airlock at 8 a.m. EDT for a demanding 6.5-hour mission that combines both maintenance and scientific investigation. Their first task will involve the removal of a radio frequency group hardware from the Destiny Laboratory module, a delicate operation supported by the Canadarm2 robotic arm. Following this, the duo will engage in a fascinating study of microorganisms by swabbing surfaces on the Destiny and Quest modules. The goal is to understand whether these microorganisms, released through station vents, can survive in the harsh external environment of space. Such investigations are crucial as they offer insights into microbial life in space, which is essential for long-term space missions, including journeys to Mars and beyond. Understanding the survival mechanisms of these microorganisms could help us develop better life support systems and sterilization protocols to ensure astronaut health and the integrity of space habitats. Support for the spacewalk is robust, with NASA flight engineers Mike Barrett and Jeanette Epps prepping the Canadarm2 maneuvers. The event promises to be an exciting display of teamwork and precision, all while contributing valuable data to our ever-growing knowledge of living in space. NASA is on the brink of a significant scientific breakthrough with its upcoming Landolt mission, scheduled for 2029. Named in honor of astronomer Arlo Landolt, this mission aims to create artificial stars through the use of meticulously calibrated lasers. These lasers will be deployed aboard a small CubeSat satellite orbiting approximately 22,000 miles above Earth. The artificial stars, invisible to the naked eye but observable by ground-based telescopes, will offer a precise benchmark for calibrating these telescopes. The importance of this mission cannot be overstated. Accurate measurement of stellar brightness is fundamental to many areas of astronomy, from characterizing exoplanets to understanding the universe's accelerating expansion. Past calibrations, dating back to 1995, have introduced notable errors in brightness measurement, affecting the accuracy of astronomical data. By providing a precise standard, the Landolt mission will eliminate many of these discrepancies, paving the way for more accurate observations and groundbreaking discoveries. Jonathan Gagné, a scientific advisor at the Montreal Planetarium and an associate professor at the University of Montreal, emphasized the mission's potential impact. He noted that better calibrations will particularly enhance fields like exoplanet research and the study of cosmic acceleration. The mission's advances promise to solve existing astronomical mysteries and open new avenues for exploration and understanding. One of the most intriguing stories in modern astronomy is that of HM Sagittae, a peculiar binary star system. 40 years ago, during the summer of 1975, HM Sagittae caught the attention of astronomers worldwide when it rapidly grew 250 times brighter. Unlike typical novae that fade away after a few months, HM Sagittae maintained its luminosity, marking it as a subject of continued fascination and study. Recently, a combination of new data from the Hubble Space Telescope and NASA's retired Sophia Observatory has revealed that the star system has become even hotter, despite a slight dimming in its brightness. These findings have given astronomers valuable insights into the dynamics of symbiotic star systems, where a white dwarf ingests gas from a companion red giant star. The disk of gas around the white dwarf can unpredictably ignite in a thermonuclear explosion, contributing to the ongoing stellar fireworks observed. HM Sagittae is particularly unique because it showcases continuous activity and changes over extended periods, unlike most novae. The latest Hubble ultraviolet data has shown a strong emission line of highly ionized magnesium, indicating the temperature of the white dwarf has risen significantly. The SOFIA infrared data also detected gas and dust movements around the system, contributing further to our understanding. These observations have underscored the importance of long-term monitoring of such rare events. Collaborations with amateur astronomers through organizations like the American Association of Variable Star Observers have been vital in tracking these changes. HM Sagittae serves as a testament to the rich and complex interplay of forces at work in binary star systems, offering a deeper understanding of stellar evolution and the violent processes that shape our universe. One of the exciting developments in lunar exploration comes from China's Chang'e 6 mission. Recently, China's space agency released information about a tiny, autonomous rover deployed by the mission. Weighing only about 5 kilograms, this mini rover, developed by the China Aerospace Science and Technology Corporation, is an intelligent marvel designed to navigate the far side of the moon. After successfully landing, the rover detached from the Chang'e 6 lander and moved to an optimal position to capture images. These photographs are not only a remarkable achievement in robotics, but also provide valuable data, helping scientists better understand the lunar surface. The far side of the moon, being relatively unexplored, holds many mysteries, and missions like Chang'e 6 are crucial in advancing our knowledge. The mini rover's lightweight design contrasts sharply with China's earlier rover, U2, which explored the moon in 2013. This progression in technology underscores China's growing prowess in space research. However, there's still no update on the rover's condition following the Chang'e 6 ascender's blastoff, which transported lunar samples into moon orbit. This mission marks another leap forward in our continuous journey to unravel the secrets of our nearest celestial neighbor. That's all for today's episode of Astronomy Daily. I'm Anna, your host, and I hope you enjoyed our journey through the cosmos. For more astronomy news, be sure to visit our website at astronomydaily.io. There, you can catch up on back episodes and sign up for our free daily newsletter to stay informed on all things space. Don't forget to follow us on social media for the latest updates. You can find us on Facebook, X, TikTok, and YouTube by searching for Astro Daily Pod. Thanks for tuning in, and I'll catch you again tomorrow for more stellar stories. Until then, keep looking up.